Hi everyone, in today's video we'll be continuing the SageMaker Inference series. You can think of this as a part 3 to the intro to SageMaker Inference, deploying a SageMaker endpoint hands-on. I'll link both videos down below in the description just for your reference. But what we'll do today is we'll take kind of the next natural step in understanding SageMaker real-time endpoints a little more, and really what I want you to take away is how can we productionize them, use them in a real-world setting. That's kind of the idea behind this whole series, and that's why we did debugging in the video before this with Docker, just to explain how you could kind of simplify the process of creating these endpoints. Now what we'll do is something known as load testing, and we'll showcase how to specifically do it in the context of a SageMaker endpoint. And before we even get to that, as you can see in kind of our usual breakdown here, we'll talk about what load testing is, why should we do it exactly if we want to productionize not just ML workloads, but just any general workloads we might be working with. We'll talk about different load testing tools and more specifically Locust, which is what we'll be using today. And then we'll dive in, as always, specifically into SageMaker itself. Kind of like there's always these different concepts that we really just incorporate into SageMaker or whatever tool that you're using. And I think load testing is an essential one. So we'll take Locust, we'll specifically apply it to the SageMaker real-time endpoint that we created beforehand. And we'll kind of demystify and explain what exactly is happening in this endpoint from a performance perspective and how can we tune it, what does it exactly mean, and that's when we'll get pretty hands-on with the demo. But as always before, I did want to hop over into the whiteboard itself, so let me first get out of this slide here and start sharing screen, and we can kind of draw out some of these concepts just to explain it. We'll return to this diagram in a second. That will make sense very, very shortly. But what we first want to cover, right, is what is load testing itself? And this is something when I was more novice or new into the workforce that I did not really know much of. Probably should have taken my testing class a little more seriously. But in terms of load testing itself, right, we hear of unit tests, we hear of different types of things like that. Load testing really comes into play, and it's also known as stress testing, when we really want to see if our application can uphold with the load that it's expecting or that we might see at peak. And what I mean by this is something known as transactions per second. So for example, if you think about Amazon on Prime Day, you can imagine the number of users that are essentially accessing the application itself. And you can imagine behind the scenes, there's a number of services that are probably working together to be able to handle that kind of throughput. And you can imagine this as throughput. This is another word that I'll use often. You want to ensure that your application can handle the traffic that's really coming in. And oftentimes, throughput, there's two different angles you can look at it at. There's the transactions per second, there's also the concurrency with which you're getting these requests. And it's very, very important in the traditional software world and also the ML world, as we'll see today, that our application, or in this case, our model, no matter where it's deployed, whether it's SageMaker or anywhere else, we test it to ensure that it can handle kind of the throughput that we're generating, that our application is expecting. And now the second key component, right? Throughput is number one in terms of this, like in terms of one of the factors there. The second key component, and I'll just change over to another color for this, is latency. Because yes, let's say our application can handle all the requests that are coming in, but if it's not returning something in a time that we find sufficient or acceptable for our application, then that's also going to be a cause of concern. So for latency, you really want to think of this and throughput as going hand in hand. Can I handle the load that's coming in, but am I still returning a request at a rate which is acceptable for my application? So imagine you're kind of like a user on Amazon, Prime Day, you're shopping, you're kind of building your shopping cart, and there's just a lag, or it's adding items, but it's not at the rate that you're expecting. That analogy might be a little mixed up now, but something along those lines, right? Where you can imagine you need a combination of both of these. And that's why oftentimes before productionizing, people will often talk about SLAs or just kind of performance requirements where they have a P99 latency that they need to achieve at maybe, let's say, 100 transactions per second. Maybe you need a P99 latency of 250 milliseconds while achieving 100 transactions per second. So it's very, very key in the real world when you're working with ML or software that you kind of understand these metrics beforehand and work backwards from them. So you have an idea of these are the kind of goals or targets I need to achieve. Here's my serving stack or my software application. How exactly can I tune this to achieve that, right? And these are two words you'll continuously see as you productionize your ML workloads. And This applies once again not just in the ML space, but any general software application. So always think about a combination of these two. And sometimes there might be workloads that are more throughput sensitive. Sometimes there might be more workloads that are latency sensitive. So you always want to design your system depending on what your exact requirements are here and work backwards from that. And the need for load testing, right, is we want to obviously not test this in production. We don't want to launch a application with a model and then say, and then we unfortunately find out, oh wow, it can't handle this traffic, or at this traffic rate, the latency really spikes up essentially, right? And that's where load testing was essentially introduced, where we can essentially simulate traffic to our application. So we're going to simulate the traffic and we'll monitor both the throughput and the latency for us to be able to understand how exactly our system is performing, right? So a combination of these two is once again what we're going to try to achieve in our load tests, and obviously you can tailor this for your situation. And to make this simple, a lot of different tools have been released in the world. There's also JMeter, which I believe is a Java-based testing engine, but for the simplicity of today, we'll use something known as Locust, which is a open source Python framework. I've just always been more of a Python type of guy, maybe because I've always been in the ML space using these libraries. But here with Locust, we can essentially simulate large-scale load tests. So if we need to really ramp up the traffic while monitoring metrics such as the latency, we'll have an idea of that, right? So Locust, JMeter, you're not forced to use any kind of tool. Use whatever you're comfortable with if you have familiarity with a certain framework. But this is at least our kind of point of contact or kind of tool that we'll be using for the tests today. So that at a high level is what load testing is. Really, I might have simplified it, but it really comes down to monitoring those two kind of metrics. And there's obviously kind of like kind of headers or terminology or vocab that you'll see, but everything kind of really streamlines or kind of revolves around these two factors. With that being said, in terms of load testing itself, the next thing I did want to revisit before we get hands-on or go into the UI is, right, the SageMaker endpoint itself. So we've talked about how load testing can be applied anywhere, but let's talk about SageMaker endpoints specifically. If we remember a SageMaker endpoint, right, it's a real-time REST endpoint that has a certain amount of hardware behind it. So right here, this instance that I've pre-drawn is the hardware or the compute. So whatever kind of CPU, GPU, or whatever special chip you might be using behind it is essentially the compute power that's behind it. And this, once again, we'll talk about a little more later. You can scale this out. So you can increase your instances by applying auto scaling. That's going to be in the next video. I feel like I keep saying that always, but we'll follow up in terms of that after we learn how to load test. But here, you have your instance, and you can, once again, scale this out. And more importantly, we also talked about the model container or the serving logic itself. This is once again the model server where we implement our inference scripts and any kind of model serving logic that we might have while also tuning that server for performance on the server side. And then we have our user right here in red, and that invoke endpoint API call is essentially our point of contact. That's how we talk to this SageMaker REST endpoint. And what we're going to monitor in our load tests is that invoke endpoint API call. So we're going to tell Locust, this is the REST API call that we're essentially monitoring. This is what we're working with, and this is what we're going to be monitoring in terms of throughput and latency as we hit this API call. So this is our point of contact almost, and we're going to specify that in our Locust script as we see later. The crucial part here is there's different types of latencies. Latency is not a standalone kind of thing or object. You might have end-to-end latency, right? And let me write this out right here. You might have end-to-end latency, but there's different aspects, right? So within SageMaker itself, you might have something known as model latency. So this is everything that's happening within that container, right here, which we're talking about. That container, right, once again contains our inference script, any serving layer logic that you might be implementing or working with, and anything that's happening within that, that itself contributes to the model latency. And you'll see SageMaker captures this as a metric that you can monitor and work with essentially. So that model latency is anything that's happening within the container. And this is usually what's under the user's control, because the user can adjust the inference script. He can tune some of the model serving layers such as queue size or kind of like worker count, things of that sort, to kind of really test different combinations or permutations. This is oftentimes within your control, and at kind of high performance serving or scaling, you have to really revisit. This is why I was trying to say a model server is so important, you really have to revisit that model server and whatever code you might have in there, right? And understand how you can tune it, because this is essentially our tunable parameters that we're working with. A second thing that's introduced right here, right, and I have it pointed in red here, this is the SageMaker overhead latency. And this is what's introduced by SageMaker itself at the application layer. And once again, this can kind of like, this can also like adjust, or it can vary depending on like your exact use case, your payload size, but you don't really have much control over this. There's not too much control over the overhead latency itself. This is what SageMaker introduces. And then you also have to keep in mind, right, the third latency here, in terms of the user itself, there might be some network latency. So depending on where you're invoking it from, this obviously has a big impact. If you're in the same VPC, same kind of networking setup, wherever you might be working, right, then it might be minimal. But if you have a lot of different network hops, then this is obviously might be a substantial amount. So what you really want to think of or take away from this is the model and network latency are kind of within your control, where you're invoking it from, what exactly is happening in the serving layer with my inference script, and any kind of parameters I can tune at the serving stack itself. And then also this overhead latency is a third component, which is normally minimal, but you want to keep an eye on it to see how exactly it's kind of like impacting your end-to-end latency. So that's kind of a breakdown of how a SageMaker endpoint itself looks. And I'll explain why we're not auto-scaling here in a second in the hands-on, but let's hop right into the code itself, actually. I want to get right into it so that we can spend more time walking through what I'm sharing. The code is in this GitHub, as always. And what we're going to do here is, right, we're going to take this notebook itself that we have. And in this notebook, what we'll walk through is we'll take the SageMaker endpoint that we've created in the previous series. So right here in part 1, I'd suggest maybe revisiting it if you want to understand how to actually create the SageMaker endpoint itself. But what we'll do is we'll take that same model and have some of these scripts for kind of generating that model and stuff pre-built there. We won't really explain or dive into all of it. Like, that's all going to be in part 1 once again, in terms of actually creating the endpoint. But what we'll do is we'll explain kind of this locus script that we have here and the load testing itself within the notebook and how you can maybe scale up from it for future experiments that you might have. So let's get right into our environment here. I'm in SageMaker AI. It's been renamed to that recently. And here in SageMaker AI, I have a notebook instance created, where I have a instance, pretty small one, where I'm going to essentially run my load tests that I'm working with here. So if you see here, once you open this, and once again, you can also use Studio or a different development environment. The one thing I recommend is you need to have enough compute to be able to run these load tests. So if you run this on your PC, you're going to be restricted. Basically, the load test only has access to whatever cores or workers you might have available. So ensure that you have enough compute wherever you're running it to be able to run with this. But for the sake of simplicity, we'll use this notebook instance right here, and we'll hop right in. I'll go over to this notebook section here as we saw in the Git repo. And if you see, once again, the first notebook is also in the same directory right here, this parent directory here. You can grab that, you can follow along with the video, I'll link it down below, and you can see how to create the endpoint. We'll just kind of jump through that quickly here. And what we'll introduce here is using Locust itself. And I've also linked the documentation down below. But with Locust right here, we can see that it's, once again, just an open source Python API. And you'll have the GitHub link as well if you want to access that directly. And within Locust, what we'll explore is how can we essentially write something known as a Locust file, and these Locust tests and these different kind of objects that Locust has right here. So we'll specifically walk through that, understand that, and apply it to SageMaker itself. And as we walk through here, right, let's get right back into the notebook. You'll see the same usual setup. We have our SageMaker and Boto3 API calls that we're working with. S3, ECR, once again, these are all processes that we ran before in the previous notebook. We deploy this end to end. We take our SageMaker scikit-learn model. I have this job file already in the directory. It's probably not best practice. You should not do that. But this is a serialized model data. We create our model data object. We essentially tell SageMaker this is a scikit-learn model endpoint. Here's the container or the serving stack I'm using. I create those same entities that we talked about before, the model, the endpoint configuration, and the endpoint object. And then as you can see, I'm able to invoke this endpoint on demand as I need. And once again, this is the key API call here. This invoke endpoint API call is what lets us talk to this SageMaker endpoint right here. This sklearn DGL EPSME right here. So we have that built. and created beforehand. This might take a few minutes end to end if you're just getting along to it now. So take some time to run through that and you can revisit to this section. And now the key part, right? We have our SageMaker endpoint. We want to build a locus script, which allows for us to work with this SageMaker endpoint. So if I go into locusscript.py right here, and I've also added a kind of starter locus blog down below for you to just get some more familiarity with it. We'll talk at a higher level about the different concepts here. But you'll notice here, I've created a Boto client class, and I'm essentially capturing my SageMaker invoke endpoint API call. So in this try catch block right here, what I'm doing here is I'm saying this is the endpoint call that I'm invoking with, and I'm going to pass in my endpoint name, my payload, content type, the usual parameters that we have. And this is essentially our point of contact that we're working with. And this is once again all just Python specific for invoking the endpoint. The actual locus code where that comes in is I define a user, and for that user, the task, so a locus task, this is a object specific to locus. This is the actual API call that we're measuring, which in our case is the invoke endpoint API call. So we take our Boto client, we instantiate that, and we say that the task that we're essentially monitoring is this method right here. And in this method, we're doing that invoke endpoint API call, right? So in Locus, the key thing you want to understand is this task right here. We're simulating essentially the API call that we want to load test or work with. So there's not too much more to it there. That user you can think of as someone that's using your application or working with it. And this is the method or API call that we're testing. Another little knob that we introduced here, right, is this shell script. And the reason we have that is we want to make this locus script run in distributed mode. And this you might not see the full relevance of it in a notebook setting, but let's say that you want to generate up to thousands of transactions per second, which we're not doing in this case. It's really hard to do that on a single Python process, which is what happens by default. So what Locus enables you to do is you can essentially scale up your users, which is essentially right the number of users maybe that are expected to use your application, and your workers, right, is essentially kind of as you scale your tests, the different users that you're spawning are distributed across these locus workers. So rather than having it run as a single Python process, we're running it in distributed mode. So you can think of users as a bit of a multiple of those workers, right? So the users are the ones who are actually hitting your application. Those workers is what locus is spawning, and it distributes the different users across those workers. So if you have 240 users and 60 workers, you can imagine 4 users per worker, unless I botched that math there. So you can scale this, right? So if you want to generate more and more traffic or increase your traffic and workload rate, increase this user count here, and proportionally, as long as your client machine, right, has enough compute once again, increase this worker count. And you want to be careful with this because, like I said, if you're not running it in a large enough box or instance, and you don't have enough workers to generate this much traffic, you're going to run into problems. And that's why a lot of people use something like EC2, where they have multiple instances and run in distributed mode, because then you can really scale up your traffic to even from thousands to tens of thousands to hundreds of thousands of kind of transactions per second. You can also adjust the runtime here. We essentially parameterize the locus script here. This runtime is essentially how long you want the test to run. So I set it for 1 minute just for the sake of demo here. And if you see here, this is my locus script. That's the point of contact for working with locus once again. And then I'm going to run this in distributed mode essentially. And here, if I run this shell script that I essentially have, I run this and pass in the SageMaker endpoint name into the shell script. You can directly adjust this, right? So if you're testing a kind of different model or different endpoint, you can adjust the payload here for your expected payload. You can adjust the content type, and you can adjust the endpoint name. So the script is very reproducible if you're working with the SageMaker endpoint right now and you want to essentially test it. I run this, and if you see in live, it starts generating requests. And you can monitor different kind of percentile metrics. So let me run this live once again, but I want to show the results down below. So if I instantiate this test right here, or sorry, not instantiate, if I start this test right here, you'll see these requests are being created and generated in live. And you'll see the requests per second, failures per second, it's a little hard to read there, and then latency metrics that are also being generated at the same time. And what I did for the previous test here is I already kind of captured all of that, and Locus will automatically generate these different kind of results metrics here. And if you go to this results stats.csv, this is from the previous test, what you'll see is there's the transactions per second, any failures, and also more importantly too, you have the different latency metrics. So you'll see your P99 end-to-end latency, what exactly is happening here. Now this is great, right? Locus captures throughput and latency, but as we talked about, SageMaker's a little more nuanced. There's like different parts within it, the model latency and overhead latency, and you can also monitor these while your tests are running. So if I come to this endpoint tab right here, and I click the SageMaker endpoint, what you'll see here is that there's different operational metrics. There's one, the hardware metrics itself, then there's the invocation metrics. So what I'm going to do is I'm going to toggle these invocation metrics for the past hour. I'm going to look at the sum of them, and I'm going to see how many invocations I've essentially generated in this past minute. So you can see 2.9K invocations in the past minute. And it's very important to compare this, right, to also your hardware metrics. So in this case, we have a CPU instance that we deployed on. And you can also click on information right here to understand what each of these metrics means or how you can interpret them. But here, essentially, you can say sum of the CPU cores. So how much utilization I have here, essentially, that I'm working with. You can see the sum of the CPU cores and you can see how saturated your instance is, essentially. So if you have about 400% kind of saturation that you can achieve, because there's 4 cores, 4 times 100 is 400, you want to see, am I really using a lot of my instances compute? And let's say 400 is kind of the peak bottleneck, and you're at about 380, then you have an idea at, okay, maybe at this amount of requests per second, that's when my instance is really likely to shut down or start returning errors. And that's why it's a really important product, right? To compare your hardware metrics versus your invocations, because that is what will let you decide how you need to scale out. And that's essentially what we'll reach next time, right? In our kind of next video in this series. And I promise I'll release that a little faster. But you want to find the right formula between the invocations, where am I exactly getting bottlenecked, in terms of when is my hardware getting saturated enough. Normally, the rule of thumb I have is around 80 to 90% saturation. I should probably start scaling out to be able to handle that peak traffic. And that combination is really what will help you derive your proper scaling policy. And a little kind of sneak peek, I guess, into that, right, is if you go to settings, you can notice here, if you tap on this, you can configure auto scaling, and you'll see that you can specify a metric known as invocations per instance. And you can specify scale in, scale out. We'll talk about all this later. But when we have an idea of how many invocations per instance will really bottleneck our endpoint, then you can kind of determine your scaling policy, right? And that's why I often test on a singular instance, because I want to understand how much can this instance type handle before I exactly go and define a scaling policy to have like a more robust handling of traffic. And I think that's mainly what I wanted to cover for today. Make sure you delete your endpoint as always to not get any more costs right here. And what I'll also link just for more reference is like kind of the official AWS blog for load testing these endpoints. And then I'll also link the official metrics here just for you to understand further. If you're going to use SageMaker as kind of your tool of deployment, it'll be good for you to understand in a much more clean way than what I drew out what the latency looks like end to end, what are the different metrics that I can scale from, and just in general how to exactly performance tune SageMaker endpoints. So I hope this video was a helpful introduction in that sense, and we will be back with more. If you like this video, please feel free to like and subscribe it as always. And any questions, reach out to me directly on LinkedIn, Twitter, anywhere. And yeah, appreciate the support always. Thank you all, and I will be back very, very soon.